Welcome to Beyond Lab Walls, a podcast from the Salk Institute. We're taking you inside the lab to hear the latest discoveries in cutting-edge neuroscience, plant biology, cancer, aging, and more. Explore the fascinating world of science while listening to the stories of the brilliant minds behind it. Here at Salk, we're unlocking the secrets of life itself and sharing them beyond lab walls.
Welcome to the Salk Institute podcast, Beyond Lab Walls. I'm Isabella, and today I'm sitting down with staff scientist Emily Manoogian to talk about circadian rhythms. Emily is a chronobiologist, a title she once didn't even know existed. She works in Sachin Panda's lab here at Salk, which is filled with scientists trying to unravel the many ways circadian rhythms underpin our health. Emily is helping us figure out how to live more intentionally with these biological rhythms in mind so that we can all live happier, longer lives. I'm really excited to get into this conversation and get to know more about Emily. So, Emily, where did you grow up?
So I grew up in Sanger, California. It's in Fresno County. It's kind of one of the more rural areas. So when you see you got raisins or almonds or whatever other produce from California, that's probably where it came from.
Did that setting inspire an interest in science?
I really have always loved animals. I lived on like a 2.5 acre lot and it was surrounded by agriculture. And so we had a lot of like outdoor cats and dogs, and I've always had animals around me, and you know, the neighbors had chickens and there's cows down the road. So I was very around animals in that way. And I originally had decided I was going to be a veterinarian. And then that ended up not working out for whatever reasons, but it had gotten me into a biology major in college. But actually, when I was really young, I loved math and I hated science. I remember going to a STEM event and being like, I'm only here for the math. I really don't like science. And I think what it really was, it wasn't that I didn't like science. It's that I wasn't into geology at the time. You know, I mean, like what our education system defines as science is so many different things. And you don't actually get into like applying logic and thought and experiments until you're much older. And so when it got to the point of like my kind of science now, I guess I really fell in love with it. But when I was a kid, yeah, I was everything but science, or at least what I thought was science.
What is chronobiology? How did you get into that as a focus?
Yeah, I mean, I didn't know it existed either until I was in college. So it all started by taking a class. It was my second year, and I was an integrative biology major. And I was thinking maybe plants or maybe that, I wasn't sure. And I ended up taking this class called Hormones and Behavior, and I just loved it. I loved it so much. It was so interesting. It was neuroendocrinology and seasonal reproduction. And there's a lot of circadian components to that, or not just circadian, but biological rhythm components. There's many different types of biological rhythms. Circadian, which is a daily rhythm, is just one of them. But especially when you think about seasonal reproduction, you have these circannual rhythms and like menstrual rhythms and tidal rhythms, and you have all these different things. And I was so fascinated with it. And I was talking about it all the time, and I just kind of fell in love with it. I just kind of bothered him until he let me into his lab. And so then for the next 2 years, I worked in his lab, and I found I just loved my time in the lab. And I was like, well, that's what I should be doing then. And so that kind of bordering between circadian and neuroendocrine led me to UMass Amherst. For the first 6 months, I was doing more neuroendocrine stuff. And then that very quickly transitioned into more strictly circadian stuff. And
can you tell me about making the switch from animal models to humans?
Yeah, so I used to work on hamsters, and almost no other field uses hamsters. Chronobiologists use hamsters because they have extremely precise circadian rhythms. Like I could tell you when some of these animals were going to start running on that wheel, like with a countdown almost to the second. They're amazingly precise. And I was looking to do my postdoc. I was trying to figure out what am I going to do next. And a lot of the advice I'd gotten, I think is still advice that you get is, think about what's going to be exciting in 5 years from now. Like figure that thing out. And what do you want to be an expert in 5 years? And so for the last couple of years of my grad school, I was inviting professors to come give talks at UMass. And one of the people I invited was Sachin. And I loved his work, but I originally thought there's no way I could work with him because I think I do want to get out of the rodent space. I want to try something different. And that's when he told me about the human work that they were doing. And I was like, oh, well, that I'd be very interested in.
What excited you most about moving into humans?
The field is so new to, well, can you improve these rhythms to improve health? And that's kind of even where some of the animal work was starting to go. And then when I talked to Sachin about his work in time-restricted feeding and then translating it into human work, it was just such an exciting opportunity to say, we now have a system that we have basic, hardcore evidence for. It hasn't been tested in humans yet. This seems to be like a pretty low-hanging fruit that might be a major thing. And I mean, it's a totally different system. Working with humans is very different than working with hamsters. But the biology is the same. It's all based on the same ideas. Human circadian rhythms are much easier to relate to. And it's, everyone eats, everyone sleeps. You can understand this at just a more basic level. It just makes sense because we all live it.
So in practice, what are circadian rhythms doing? Are these rhythms mostly impacting metabolism?
Yeah. So circadian is literally just Latin for about a day. And how everything in your body works has pretty much a circadian rhythm. We know that that metabolism as a whole, like almost every component of it, has some type of circadian regulation. So it's not to say you can't digest things or eat things at different times of day, but you're going to be better or worse at it at different times of day. The way your glucose is going to respond to food is going to be different at different times of day. If you break down fat or not will depend on nutrient availability, and that's usually time. And so, yes, it's super tied into metabolism at so many levels that it's hard, you can't just like name them all. It's almost like on every molecular circuit, you can usually find a circadian component. And we know that there's a lot of specific, when you think of metabolism or metabolic health, that are directly tied into circadian regulation.
Oh, so you can have dysregulated circadian rhythms in different spots in the same body?
Yes. Yes, you can. So there's kind of like three main things we think about as external cues that impact your circadian rhythm. The first one, I think what was the focus for so long, was light. And light directly impacts the kind of central clocks in your brain. And those are going to more directly affect your behavior, like when you're sleeping, when you're awake. Now that indirectly usually affects when you're eating, because when you're asleep, you're not actively eating. But when you eat is another really significant cue. And those directly affect the clocks throughout your body more directly than light does. And so if you invert food and time, you can completely switch those clocks into antiphase of each other. I mean, just completely. It's amazing to see how fast they switch. And you cannot shift the clocks in your brain with food, and you cannot shift the clocks in your body with light. And so, yes, when you misalign your behavioral rhythms, you can break parts of your system, or at least misalign them where they're now not working together properly.
To focus in on those sleep-wake patterns and light, how might someone living somewhere with really long days or nights impact someone's health? Or in places where winter days are very short and summer days are very long, does that make you an entirely different person health-wise based on the season?
Yeah, no, that's a great question. And I think, when you think about these extremes, it gets a little weird, right? It can be very hard to not have light for long periods of time, right? To have weeks without light or extremely small amounts of light. And that can lead to other issues, even if you forget the circadian component of it, that, seasonal affective disorder is a very real thing. You see this a lot, even on like the East Coast, like New England. When you are outside, it's very dim or it's too cold and you don't get enough sunlight. And having sunlight all the time can also be disruptive because light is such a strong cue. So the thing is they've found ways to adapt. So they usually have extremely good blackout curtains. So they can create a dark space whenever they want to create a dark space. But I'm sure that has some caveats. You don't want to go from full bright light to just dark and then you'll respond normally, right? Like you naturally kind of do need this dimming. And I think they do that to some extent. And then they use a lot of artificial light, like artificial light boxes that are these really bright lights to try to create that. I mean, you got to remember too that the circadian system can run on its own. It doesn't need external cues. If I put you in a cave, you're still going to have circadian rhythms, and that's without any types of time cues. The problem becomes is that without light, it's hard to entrain to stick to exactly 24 hours because none of us are exactly 24. We're usually a little more or a little less, but not to be exact, right? And so this is where you actually get into a situation like for people who are blind, depending on biologically how, or if they block their vision with sunglasses or whatever, then they can't entrain to light either. And what happens is you slowly start to shift, right? Say, imagine your body thinks it's 15 minutes later every day. After a week or two, your body thinks it's a totally different time of day than it is. And so the other way that sometimes people cope with this is by taking small amounts of melatonin at night. Melatonin is both circadianly regulated, but it also helps influence your sleep and when you stay asleep. And so that can sometimes be enough of a external cue to help synchronize people to keep their behavioral rhythms on track, even in the absence of light.
These are such huge questions you're asking that span diet and exercise and light. How do you actually study circadian rhythms in the lab?
Yeah, so I used to look a lot more labby when I was working with animals. Now that we're working with humans, most of the time we're in an office space. We do have a clinic, so we collaborate with UCSD. The humans that we work with usually come into the clinic there and they can get blood draws or DEXAs or muscle biopsies or whatever else we need done. And we have them do all their procedures there. And then we communicate with them virtually a lot of the time. So phone, Zoom, text, and we do see them at their visits. We go and run the visits. But aside from that, we're in kind of like an office space. But that's really just the clinical team. The other parts of Sachin's lab that are more wet lab, it is what you would think of as a traditional lab where you have a lab bench and pipettes and chemicals and all kinds of other things around. But my day-to-day is usually at a desk.
A part of all of that is the app you and Sachin have. Can you tell me about it?
Yeah, so the My Circadian Clock app, it's one of these rare research apps that is been maintained for a long time on both iPhones and Androids. This really all started because when you think about food and nutrition and like food logs and when do people eat, no one really knew when. I mean, everyone was looking at what or how much, but no one really was looking at when you actually ate. And if you said when, it was like breakfast, lunch, dinner, or snack, but there was no actual time component to it. Or if there was, it was just like a few days maybe. And we know humans have crazy amounts of variability in when they eat. And we are also notoriously bad for remembering when we ate. And it became this question of, well, when do we eat? And can we understand this? And is this even an issue in humans? And so the app was devised to understand that timing. And so it took away a lot of the burden of a lot of other food logs where you're trying to get exact calories or exact quantity and that kind of thing that take a lot of time to enter. And it replaced it with a quick picture or a name or just a name. You could say burrito if you needed to, which obviously we don't know what's inside that burrito, but we know you ate a burrito. And it timestamps it. And we track this usually for a minimum of 2 weeks, and in some studies over a year, so we can understand when people are eating and how that affects them. On our controlled trials, we use the app as a way to understand their baseline levels, but then also to implement an intervention and communicate with them and monitor them. And then the app is also available for anyone in the world to use. Its main limitation is that it's in English only at the moment. But it is free to use, so you can track what your rhythms are. You can set your own goals. You can enter health factors if you'd like. So it is a really cool tool that we're able to provide to people. And it is completely commercial free. We don't make money off this at all. There's no ads. It's a free service to use. So yeah, if you're interested, go ahead and download it. My Circadian Clock. You can find it on your app store.
No ads. Very appealing. To get more into the eating research, I want to dig into a specific study of yours, the firefighter study. Can you explain to our listeners what the firefighter study is and what you found?
Shift work is a huge problem. This is a good example of your behavioral rhythms throwing off your internal clocks and having negative health consequences. But it's not like I can just say, well, don't do shift work. We need shift workers, right? The firefighter study became known as the Healthy Hero Study because really most shift workers are, the heroes of our society. They're protecting us and taking care of us. It's a very necessary burden that people carry. We know that it's linked to increased rates of cancer and almost every form of chronic disease. And these are people who usually start pretty healthy. If you're thinking of firefighters or nurses or doctors or police officers, they usually start very healthy, but they develop cardiometabolic diseases very early. They have higher risk for cancer. We know that there's an issue going on there. A big problem in shift work too is that they are almost always excluded from research. I do this myself because doing shift work is extremely confounding. You can't just mix that person into the data set as if they're normal, quote unquote normal. Obviously they're a normal person, but they have such a different lifestyle than other people who aren't working shift work. So when you're going to do a shift work study, it needs to be an only shift work study. And even on that level, it needs to be the same kind of shift work. The other reason why there aren't very many interventions is because what are you going to do? Tell them to sleep more when they have to be awake? And there have been studies that have just tried to help with sleep hygiene. Like, these are good sleep habits. These are things you can try to do when you're off. These are things to make it easier to sleep when you're off schedule. And I was amazed when we did a 24-hour ride along with San Diego Fire, and they were doing everything right. Every sleep hygiene thing I could think to tell them, they were already doing it. So what do we do? And this is where TRE came in to be super exciting of, okay, I can't change when you see light. I can't change when you sleep. I can change when you eat. And firefighters were actually some of our lower hanging fruit there, because firefighters generally work either 12 or 24-hour shifts, but they are allowed to sleep between calls at night. So in quieter stations, they're still at least trying to sleep. So it's not great sleep, but they still get to try to sleep, and they still eat their meals during the day. But we knew they were still eating really late into the night. You'd get a lot of things like spared feed brownies brought in, or a donut pickup at night, or other different things to kind of cope with it. And so we knew they were still eating late. Well, what if they just didn't eat at night? And we did allow black coffee whenever needed. We encouraged them to consume it during their eating window if they were able to, but if they needed it, to go for it. They were able to do it. They felt like they had more energy. Like, I feel better now than I did before. And a lot of the participants in that study were healthy to begin with, and a lot of it was feasibility. But in the groups that we had people who did have, elevated glucose levels, we saw significant improvements in that group. And the ones who had elevated LDL, or like bad cholesterol, they significantly improved as well. And even in the full population with mainly healthy people, we also saw reductions in some of these other cardiometabolic markers like VLDL, which is what forms these plaques that lead to things like heart attacks and strokes. So that was super exciting to see, like, one, this is doable. Even if you're working a 24-hour shift, eating within 10 hours is a very possible thing to do. And they actually feel better on it. And so that was our first kind of toe into shift work. And it really kind of has become a bit of a passion. And I'm running my own study now on night shift nurses and nursing assistants who are working these night shifts that are 7 p.m. till 7 a.m. And that is trickier, right? Because they're trying to sleep during the day. They don't get to sleep at all at night. They're awake the entire time. And it's a totally different challenge. And so it is a bit of a different study as well. But we're trying to see, is it possible? And if it is, can it help?
It's so true. These people are heroes, but are really sacrificing their health to be the heroes we need. It's incredible to find this relatively simple way to improve or recover their health while they're still doing those very heroic jobs. I'm curious, this isn't specifically related to shift workers, but what you're saying about firefighters' long shifts has me wondering what your stance on napping is.
I think napping is your body telling you you need rest, right? And if you're able to get enough sleep at night, most people don't need a nap. If you are consistently not getting enough sleep, maybe you need a little more sleep than someone else. For adults, the general standard is 7 to 9 hours. And some people feel great with 7 hours, and some people feel awful unless they get a full 8 or 8.5. If you're someone who really needs 8 or even 7.5, and you're always getting 7, you're going to kind of have this chronic buildup of, a little bit of sleep restriction. But that can build up. And a nap is usually saying, I need rest for whatever reason it may be. There could be a homeostatic drive, like you had a really super intense physical or emotional or something event, or it could be this kind of build up over time of, I am just really tired. And so I think if you are capable of napping, it probably means you need to nap. Now, on the other side of that, I wouldn't overnap if you don't need to, because if you nap for a lot during the day or later in the day, then you'll probably have a hard time sleeping at night. There's a lot of personalization in that. But I think if you find yourself being really tired, especially short naps can be quite rejuvenating, of like a 20-minute nap or a 30-minute nap. I think when you get into the multiple hour naps, either you have severe sleep restriction or you're sick or something else is going on, but you shouldn't need multiple hour naps every day unless you're a toddler or younger. But yeah, naps can be a wonderful way to help yourself catch up on a little bit of sleep when you need it.
Okay, another sleep question. Are early birds and night owls a real thing?
Yeah, so there's this phenomenon called chronotype. And chronotype is really how you interact with your environment. And this comes back down to your even molecular clocks in individual cells. So the amount of time that it takes for one cycle of these proteins interacting with each other is about 24 hours. And if you have shorter than that, then you're an early person. Or even if you're on the closer to 24. The average for humans is like 24.15 hours as our period. So most of us are slightly longer than 24 hours. The shorter your period is in your internal clocks, and really at the level of your central clocks in your brain, the shorter the period that is, the earlier of a person you get, because your relationship to your environment is that maybe you wake up before the sun comes up or right when the sun comes up, rather than a little bit after the sun comes up. So you think about it as like a relative phase to external cues. And the shorter your period, the earlier you wake up. The longer your period, the later you wake up. This isn't even consistent throughout your lifespan. So when you are younger and much older, you actually have a slightly shorter period. When you're going through puberty, your clock starts to delay. So this is why a lot of teenagers like to sleep in, is because they actually probably have a later clock. There's some debate about how much of this is just behavioral, right? Like how much are we artificially keeping ourselves awake and would have been able to fall asleep if we turned off lights and turned off food and turned off stimulation. There's actually a really cool study from Ken Wright's group in Colorado that took people camping, mainly like college-age students. And so the only light that they had was natural light or firelight. And almost everyone became an earlier version of themselves. So a lot of this probably is somewhat related to these external cues that we can adjust, real diligence of turning things off, and that can definitely help. But yes, there are natural early birds and there's natural owls, and there are some very rare but true circadian mutants where you're these extreme early or extreme late, and those are not behavioral at all. Those are actual mutations to the clock. And honestly, those types of people usually do much better on a shift work schedule that can adapt to when their body would normally want to be awake.
Okay, that totally explains why camping always feels like the best sleep or sleeps of my life.
Yeah, or just a big power outage. I know my first year in grad school, there was a giant snowstorm before the leaves had fallen off and power was out for weeks. And when you have no entertainment, you do go to bed earlier. You go more with the light and then you're more rested. And so you wake up a little earlier. So I think there is a lot of behavioral things that you can do to try to help yourself be an earlier person, because so much of our reasons why we stay up are artificial.
Okay, moving away from the extremes, back toward eating, what are your recommendations for an average non-shift worker person?
Yeah, so actually most of our workers are non-shift workers. And we mainly started with the focus on individuals with cardiometabolic diseases, mainly because that was where a lot of the findings were in the rodent studies that came out. Not just our lab that studies this anymore, many labs across the world are studying this. And the recommendations for a shift worker not seem to so far be the same. It's about allowing your body to anticipate, which is what the circadian system does. It anticipates what your body's going to be able to do to prepare for it. So it's about eating when your body knows you're going to eat, and importantly, when you're awake and active and in the light. And then allowing yourself to stop eating at least a few hours before you go to bed. So what that usually looks like for people is somewhere between an 8 to 10 hour eating window. So that might look like something like 10 to 6 or 9 to 7. I think 10 hours is usually completely adequate for getting, at least 95, if not all of the benefit, 95% or 100% of the benefits that you'd get from an 8-hour window. Because less than that, I think you are tapping into caloric restriction, which can also be helpful, but is separate and can be additive, but it's not necessary for all these other benefits that we're seeing. And I don't think it's necessary from a circadian point of view. But it's important that it's consistent. So if it's 9 to 7, it's always 9 to 7. It's not, I ate an hour later today, so I'll eat an hour later tomorrow. That's not what we're looking at. We're looking at a consistent window that can reinforce those rhythms that your body can anticipate and that you're able to process. Find a 10-hour window that works for you. You find you have a really long eating window right now, you can go a little bit shorter at a time. It takes about 2 weeks for your body to kind of get used to your new time. So if you're at like a 16-hour eating window right now, don't go to 10 tomorrow. I think that's a little insane, unless it's just like wine or coffee that you're cutting out. But if it's actually meals, start moving them by a half hour on each side. I also think one of the common misconceptions that you're like going to be skipping meals or starving yourself, and that's not the case at all. It's really about maybe delaying your first meal a little bit and advancing your dinner, and just making sure you've got like at least an hour after you wake up for your body to get ready to process everything and see light and be ready. And so it's a matter of letting your body function the way it's supposed to.
Personally, I like my coffee with a little cream, a little oat milk latte, but that's going to mess up the window, right? Only black coffee is allowed outside of the window.
Yes, that does mess up your window. For most people, we push coffee into the eating window also. We really only allowed coffee in shift work studies, or if someone really the only thing they need is black coffee. Artificial sweeteners have lots of impacts on our metabolism. Even if they don't have calories, they do impact things. They have to be digested. There's a whole other slew of things that have to happen. So my recommendation is to try to switch to hot water, which I know sounds overly restrictive. I was surprised because I used to do coffee first thing when I woke up, and I didn't usually use creamers. I was on a black coffee kick, but I was used to getting coffee first thing. And I found switching to hot water was shockingly helpful. Of like, it still gave me my hot drink. And the inverse at night is like a glass of wine after dinner or something. It's like, yes, that still counts. So it's a matter of, trying to have those things with your meals instead of before or after.
Earlier, you were talking about how in grad school, you were thinking about things in these 5-year increments. And I'm wondering, do you still think that way? Are you always thinking in the back of your mind, what would I like to know in 5 years?
Yes, 100%. And partially is we have to. A clinical trial takes about 5 years to run. And that's how long our grants are for. So it's usually about 5 years when you'll get your answer. And you got to think about what's still going to be novel. How's this going to help us? How's this going to work with what we know? What gaps can we fill in? And also, like, what's the next thing? And so, yeah, I'm kind of always thinking on a 5-year scale. And I think time-restricted eating was tapping into one input of the circadian system. And now I think it's becoming more of this multimodal, what if we combine light and food and timing of exercise and social cues and sleep hygiene? And what if we do it as a full circadian optimization of your lifestyle? We're actually running a pilot study right now and working on a grant for a larger study to really look at these multimodal interventions for improving health span and aging, even in relatively healthy individuals. Like, as we age, health issues arise. And so it's a matter of saying, like, the circadian system is just such a core part of how all life works. We've been talking about humans mainly, but all life forms have circadian rhythms. And when you support those rhythms, you're going to be a healthier, better version of yourself.
Yeah, is there something very specific that you're most excited about in the next few years? Or is it really just like this big zoom out?
I'm really excited about the studies we're writing grants for right now on specifically some of the aging work. And we're also competing in X Prize Health Span and this is the studies we're running for that. One of the coolest things is, and so one of the other things I'm really excited about is getting more into this understanding of jet lag and travel. And when you're going on a trip, it's maybe 3 days to 2 weeks or something like that. And what's happening to you? How can you process glucose differently at different times of day, depending on if you advanced or delayed your time? And I'm really excited about that and going to be putting in grants this year to try to do bigger studies on that, because that, I think, really has the power to say, okay, if you're traveling this way, like, wait to have your sugary thing until this time, because if you do it early, it's going to really hurt you. But if you wait, you'll be okay. Some of these things where it's not don't eat the cake, it's eat the cake at the right time. Everyone knows jet lag is annoying, but like, how do you actually deal with it? And what can we actually do to diminish those effects? And so that's been kind of a fun passion project that I've also been working on that I'm excited to expand.
With this kind of research, are you like constantly thinking about how your day-to-day life is messing with your circadian rhythms and thinking about optimizing all of your behaviors all the time?
Yeah. I mean, to some extent, of course. Yes and no. If it's really late, or I'm staying up later than I should, or I'm getting light later, or I'm eating later, I know it's not good for me. And even my husband now will be like, nope, it's too late. Whatever's closed or whatever. Everyone's really bought into it, not just because of the research, but even just anecdotally feeling how they feel different if they eat late or not eat late. And we also know when to give ourselves that grace and give ourselves a cheat day or whatever, because, we've got 2 kids and schedules are crazy and sometimes are easier than others.
As someone that is so thoughtful about time and rhythms and pacing of life, do you make time for hobbies outside of the lab?
The nice thing about sticking to a consistent circadian pattern is once you're consistent, things actually fall into place a lot easier, right? It's less erratic, and it also feeds back on itself. So art has always been a big influence in my life. Through tap dance was a passion of mine when I was younger and continued to do through grad school, but also just like visual arts and painting. And actually within the past few months, I've gotten back into painting a lot more, and it's been a lot of fun. And now my daughter's almost 6, and she's fallen in love with art too. So we paint together a lot, and then we try to travel and go on hikes and go to the beach and all those fun things. And luckily, being in San Diego, we can just drive to the beach and paint looking at the ocean, which has been a huge luxury. It's been so nice. Just carry the bag out to the ocean and sit down and paint. That's my fun little relaxing recharge moment.
That sounds actually perfect. That's part of why, too, I was attracted to Salk as like the marriage between art and science. And I find that almost every scientist I talk to says, yeah, I also dance, I play the saxophone, I do this, I do that. Everyone's an artist. It's beautiful.
I mean, art's just it's another core part of being human, I think. It's just a way you express yourself. And there's so many different types of art, right? You could write or sing or draw or dance or whatever it is. We all lose time for it at some point, and then finding again can be really nice. I think art and science overlap a lot more than most people realize. And so it never surprises me when scientists are also into art, because I think there's so much overlap there.
Thanks again to Emily for sharing so many interesting pieces of the circadian rhythm puzzle that she shows up to work on every single day. Piece by piece, she's helping us figure out how timing influences health. Not just what we eat or drink, what amount of sunlight we get, or what our sleep hygiene looks like, but when. Her research is shaping the way we understand human performance and health span, the idea of living longer while retaining health. And we can all be a part of this effort by downloading the My Circadian Clock app, and we can all reap the benefits of what they've already found by staying consistent in our sleep and eating timing day to day. You can learn more about Emily's work by visiting Sachin's webpage on salk.edu. Thank you all for listening in to another episode of Beyond Lab Walls.
Beyond Lab Walls is a production of the Salk Office of Communications. To hear the latest science stories coming out of Salk, subscribe to our podcast and visit salk.edu to join our new exclusive media channel, Salk Streaming. There, you'll find interviews with our scientists, videos on our recent studies, and public lectures by our world-renowned professors. You can also explore our award-winning magazine, Inside Salk, and join our monthly newsletter to stay up to date on the world within these walls.